This is one of the hardest problems of all time in all the Blue Book practice tests, and it is one of the most dreaded problems among my students. And it's actually mind-boggling that you can solve this problem in less than 10 seconds. Trust me. So let's read this problem. It says, for an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. You know, SAT creators love to do this. They love to give some physics problem with some really difficult physics jargon, and it will be a really lengthy word problem. And most of the students just give up. One thing that you need to remember is that every SAT math problem can be solved in less than 1 minute. You just have to keep that attitude. Every problem can be solved in less than 1 minute. With that attitude, read the problem again. For an electric field passing through a flat surface perpendicular to it, the electric flux, so we have flux, that's a quantity. Don't fret over these physics jargons. So flux is some quantity, and it is defined as the product of the electric field strength and the area of the surface. So there is some electric field, the right field, and product of electric field strength and the area of the surface. A certain flat surface consists of two adjacent squares where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. Okay. We have a flat surface which consists of two squares. And one square is small, one square is big, and the bigger square is actually 3 times the smaller one. Okay. So this one is 3 times the smaller one. Okay. And the surface is like this. So that means if the smaller square's side is x, the bigger square side is 3x. I like to visually represent every problem in front of me. Okay. An electric field with strength 29 volts per meter passes uniformly through the surface. Now there is some electric field passing through the surface, and the electric field passes perpendicularly. So let's say that the red lines represent the electric field. So we have something like this going on, that's the electric field. And these red lines are perpendicular to the squares. Okay, and the strength of the electric field is 29 volts per meter, which is perpendicular to the electric field. If the total electric flux of the electric field through this surface is 4,640 volts meters, this is times, what is the electric field in volts meters of the electric field through the larger square? They are unnecessarily repeating the words. This is just redundant. So we have to find out, first of all, identify what do we have to find out. You have to find out the electric flux passing through the larger square. So the amount of flux passing through the larger square, first identify what will be that. That will be the product of the electric field times the area of the larger square. That's what you need to do first. Now there are 2 ways that you can do this question. First, I'll tell you the harder way. The harder way is the student will try to find out, you will try to find out the area of the larger square. Okay, that's the harder way. And what you will do is you will first use this information. So this is an electric field with strength 29 volts per meter. So I'm going to use this equation. Here I'll write 29. Passes uniformly through the space. So this is electric field. If the total electric flux through this surface is 4,640, so total electric flux 4,640 is equal to 29 times. So this is the total flux. Okay, so that will be the total electric field, which is 29 times the total area. Now, total area of the surface will be, well, area of the smaller square will be x squared. Area of the bigger square will be 9x squared. So total area will be 10x squared. So you'll write 10x squared here. And from this equation, you will try to solve for x. So x squared will be equal to 4,640 divided by 29 divided by 10. And using your calculator, you will get this value as 16. So x squared is equal to 16, which gives us x is equal to 4. So if x is equal to 4, that means the bigger square, side of the bigger square is 3 times x. So 3 times 4, that's 12. That means area of the bigger square will be 144 square units, meter squares. And now the flux will be flux passing through the bigger square will be the electric field, which is 29 times the area of the bigger square, which is 144. And again, if you use your calculator, 144 times 29 is 4,176. 4,176. Well, that's the answer. Now, this will easily take 2 minutes of your time. Easily, it will take 2 minutes. Because remember, you have to think out of the box. If you want to solve this problem in less than 10 seconds, you have to think out of the box. And that requires some deep understanding of ratios. Okay, so I'm going to erase everything. I hope you have noted it down. This is a difficult method. Now, I'm going to erase everything. If you focus on the equation of the flux is electric field strength times the area. So, the flux that is passing, flux is passing. I mean, flux is not passing. Electric field is passing. But the flux of each square will be different, right? Because flux actually depends on the area of the surface. Flux depends on the area of the surface, right? So we have to find out the flux passing through the larger square. Okay, so the flux that will pass through the surface will depend on the area. And if side of the smaller square is 1 unit, let's say the side of the smaller square is 1 unit, that means side of the larger square will be 3 units, because the larger square is 3 times bigger. So that means if area of the smaller square will be 1 times 1, that's 1, and area of the bigger square will be 3 square, that's 9. That means whatever is the total flux of this entire surface, only 1/10 of the entire flux will pass through the smaller square, and 9/10 of the total flux will pass through the larger square. Okay. Now, how did I get this 10? Well, this is 1, this is 9. So total will be 1 plus 9. Total area, that will be 1 plus 9, that is 10. So only 1 out of 10 portion of the total flux will pass through the smaller square, and 9 out of 10 of the total flux will pass through the bigger square. And you already know the total flux. The total flux they have given is 4,640. That's the total flux. So what you need to just find out is 9/10 of 4,640. So that's just 9 times 464. Let's see, what is that? 9 times 464. That is also 4,176. And that's your answer. I mean, it's crazy, right? How just a slight change in your perspective can save a lot of precious seconds.